Today, I will introduce to you the working principle of diodes. Diodes are made of semiconductor materials such as silicon. Pure silicon does not have any free electrons. However, the semiconductor material used for diodes is not pure, and part of it is doped with phosphorus or antimony impurities. 4 of the 5 outer electrons in the outer layer of the phosphorus atom form covalent bonds with the surrounding semiconductor atoms, and the extra electron almost unbound. It is relatively easy to become a free electron. Since electrons are negatively charged, we call them N-type semiconductors. N is an abbreviation for negative. The other part is doped with a small amount of boron. Since semiconductor atoms, such as silicon atoms, are replaced by impurity atoms, when the 3 outer electrons of the boron atom form a covalent bond with the surrounding semiconductor atoms, a hole will be generated. This hole may be filled by attracting bound electrons, making the boron atom a negatively charged ion. Since the semiconductor that generates holes is positively charged, we call it a p-type semiconductor, and P is the abbreviation for positive. On the p-n interface, something interesting happened. Excess free electrons on the n-pole side moved to holes on the p-pole side. In this way, the n-pole side is positively charged, and the p-pole side is negatively charged, thereby creating an electric field at the interface, which prevents the free migration of such electrons. Simply put, a potential difference is created that prevents the flow of electrons. Taking a silicon diode as an example, the potential is about 0.7 volts. Apply voltage at both ends of the p-n junction. That is, the P area is connected to the positive pole of the power supply, and the N area is connected to the negative pole of the power supply. Since the direction of the external electric field generated by the external power supply is opposite to the direction of the internal electric field generated by the p-n junction, the internal electric field is weakened and the p-n junction is thinned, which is conducive to the diffusion of the majority carriers in the 2 regions to each other, forming a forward current, and the p-n junction is in a forward conduction state at this time. Add a reverse bias voltage to the p-n junction. That is, the N area is connected to the positive pole of the power supply, and the P area is connected to the negative pole of the power supply, which is called the p-n junction reverse bias. Since the external electric field is in the same direction as the internal electric field, the internal electric field is strengthened. The p-n junction is widened. Electron diffusion is hindered, and the reverse current is weak. Well, that's all for today.